We are getting so close, we just have to figure out a few tooling issues first. Welcome back, everybody. It's been about 6 weeks or so since I've filmed the last episode. A lot of cool things going on here at Needlejig, so some other projects kind of took priority. And on top of that, I have been mentally working out some different, I don't want to call them issues, but complications with the manufacturing aspect of this machine. Basically, what we are looking at is the tooling. We have this tombstone here, which rotates around, and what I need to consider is that in each one of these positions, the tools are going to be coming in. So I can rotate it this way. So when I'm coming in this direction here, this part's sticking up, but when this part's sticking up, I'm actually going to be mostly machining on these two parts over here, and I don't think I'm going to be machining on this part here from the side at all. So there's very little machining on the part that's up and closest to the tooling. And then basically, as it rotates, I do have a little bit of machining on these parts here because I've got to drill and tap some holes when those point upwards. But when the tombstone's in this position, it's actually going to be working on the side pieces, the ones that are in front and in back of the tombstone as it rotates. So there's, excuse me, there's some simple complications involving the tools and the reach of the tools. Now, when you're machining parts, products, anything at all, the basic idea is to keep the tools as short as possible so that you have less stick out, it's called, and the longer your tool hangs out, the more deflection you can get. So picture a really long tool, same amount of pressure applied on it can get you more deflection than a really short stubby tool. It's just held more rigidly. So one of the keys is to hold the tools as stoutly as possible and as shortly as you can to the cutting edge. But once you start getting into fourth axis and fifth axis manufacturing, those rules got to be bent a little bit, because one of the biggest problems that I'm going to see is this part here. In the main body, if you remember, we have this bore. It's sort of an oval-shaped cut that we have down in here for clearance of the needle bar pusher mount. And so when this is being machined, it's actually at a 45-degree angle here. So let's see, is there a best way to, okay. So the tombstone is going to be held in this position, roughly 45 degrees, and the tool has got to get way down here. And in order to come down here, it physically has to pass these parts sticking out on this part of the tombstone here. So what that's going to entail is a really, really long tool holder, because if you can visualize this, the head that holds the tools really can't come down any farther than this plane here, where we have the chance of the headstock of the machine colliding with the parts. So if you could picture the headstock of the machine being up here, this is probably 8-9 inches. that the tool needs to extend down there to get to that one silly little part that we built into this. But again, the whole thing's a constant juggling act of you want to build in the features you want into the machine, but you also have to work within the constraints of the machinery I'm using. Got to get real creative sometimes as to positioning. At this point, this is what I've decided for the positioning of the parts. And for the most part, it gets everything done with the least amount of crazy tools and situations. So basically, now I have come back to this in the last 6 or 8 weeks. I get a random idea, I'll pop onto the software, I'll look at it, spin it around. I haven't made really a whole lot of changes, but making some notes, always making notes as to what I'm thinking about, where I find a conflict, trying to figure out if I do this, this solves this problem, what other problems may it create farther on down the road or for other components in this same situation. So I've been coming back to it on and off, little bits and pieces, but this morning I actually sat down, got hardcore back into the software. I had to refresh myself a little bit as to where I left off, what I was working on. And the very next step is going to be to produce at least one simple component, because this will be my first time working with the fourth axis machining and the rotary aspects and the multiple fixturings around the rotary fixture here, tombstone. So I'm going to approach that as cautiously as I can, and so I'm not going to start with the most complicated piece. I'm actually going to start with one of the simpler pieces, but it's a simple piece that presents a number of machining conflicts, let's just say, because I'm going to start with this piece here, which is the pusher bar mount, which houses the bearing here in the center. And basically the pusher bar sticks out of this end here, threads down, bends, and goes down to the cartridge. Pretty simple process, really. Really simple part. But now you look at it from this angle here, which is a side view from machining, and I'm going to rotate this 180 degrees quicker because it'll brings to light a little bit more of what I have to deal with. I've got a machine way down here on these surfaces. And in order to do that, this part here, the body, is projected way up high. So again, it's a reach thing. And a couple of the tools I need to use down here are pretty tiny. I think I'm using an extended 1/10 of an inch end mill to get in here and contour the shape of this. That still leaves the tool 1/100 of an inch is, well, it's less than 1/8 of an inch, but it's still leaves it some girth and rigidity, but the deflection is going to be ridiculous. Let me show you. Let me grab one of these here. Okay, so here, this brings it into light. So what I need to do here, in order to machine this surface down here, I need this incredibly long tool holder, and I needed this extended extra length tool to reach and get in there so that the machine head, which would be at the top of this gray tool holder here and extends out about this far here, would not collide with this part when it's coming down and machining the features into this part. So let me give you a quick idea as to what that looks like and what we're going to be getting for proximity and closeness to the rest of the parts here. I'm just generating a simulation here, and it takes a second. All right, so let me let it run fast here for a minute, and then you can see the tools. The tools won't come in from different angles. Again, the fixture will rotate. All the tools will always be coming down in from the top here. Now you can see, I'm going to stop this for 1 second. I'm going to back this one back up. But you can see where this tool comes down, where it's machining these features. Right here at the top of this gray is going to be where that machine head is. So that's not bad. And I think with the thinner tool, I actually got a lot more clearance. But I may end up switching that out because I may use that extended tool holder to actually physically hold this tool to bore that other path we were talking about earlier. But you can see where I have to take all kinds of things into consideration while I'm doing this. So, okay, so this gives me a ton of clearance. Now, if I reduce this down to, say, this is a 6-inch length holder. If I reduce that down to a 4-inch length holder, I want to say it gave me very little clearance here because I can't extend this tool out as far as I did, I believe it was this tool here. So again, this is a 4-inch tool holder, but I can feel comfortable extending this tool out a full 2 inches away from this tool holder, where the other tool, I can really only extend it maybe 1.5 inches, 1 3/8. So with the tool length being shorter and a 4-inch tool holder, that brings this plane down closer to this part. Now you got to remember this part here, this is just the part, that's not the raw stock. So let me turn on the raw stock for a minute. I think it's right here. I didn't leave a whole lot of extra material here, but I may have to leave a little more material in that for one reason or another. So it was just too close for comfort. And in the machining world, they say clearance is clearances. And basically, if it doesn't hit, you can miss by almost nothing or miss by a mile. It's still a miss. I try not to get too crazy with that because the pucker factor or cringe factor when you're watching very expensive tooling practically collide with very expensive fixtures, it's stressful. So I avoid that where I can. So anyways, this is the part that we're going to be working on. So let me start this replay from the beginning here and show you kind of exactly what's going to be happening. I'll slow it down a little bit. Hold on. Okay, so the first operation we have, that's a little too slow. Okay, so the first operation we have is just coming in, creating a smooth face on the top of the part. The other side's coming in, it's boring the hole through. Next one's going to come in and cut that final diameter so we get a nice precise fit for the bearing. That one's coming down, cutting that side of the part to proper thickness, doing the same thing on this side. Now, okay, we're coming in, we're center drilling the hole and tapping, putting the threads in the hole for the needle bar. And this is the contouring path. And there's something cool about this I'm going to show you in just a second. So we cut the contour from both sides, and I'm going to pause this for a minute. And you can see I'm leaving these 3 tabs because I want that part to be held rigidly for just a little bit longer before we about cut it free. And that's because the next process we have coming on is we're going to be chamfering the edges of the part. So that's where this chamfer tool comes in. It's going to cut the angles on there. And now we come back with another outer edge contour, and you can see I cut these tabs down to probably paper thin. I want to say that's roughly the thickness of a sheet of paper or so, maybe 3 to 5 thousandths of an inch. Let me get the models out of the way. So this is what the part would look like. Here's the chamfer's angles. The part is, I'm a little too far out there to move around. So the part's essentially complete. It's held on by 3 paper-thin tabs, and really can reach in there with my fingers and just sort of grab it and twist it free. I'll probably use a pair of pliers that are rubber coated on the tips or something, because there's going to be some sharp edges in there, and if you twist, you catch a sharp edge, and you end up with enough cuts on your fingers as it is to start with. So, but basically that is the complete machining process for that little part there. Statistically, it says about 2 minutes 21 seconds, give or take probably 5 to 10 seconds. That's pretty darn accurate, I think. And then we'll have that part made. So that is the next step, is going down to the machine shop. I'm going to, I think I'm waiting on 1 or 2 more specialty tools that I need. The extended end mills or something haven't arrived yet. So those, now that I know what I need to complete this part, everything's on order. Everything should be here soon. And the next thing you will see is the actual machining of this part. So that may be in this video, or it may be a separate video of its own. I'm not entirely sure. It just depends on how long this is. You know me, I kind of lose track when I'm sitting here trying to explain what's going on. So while I wait for those other parts, I will finish creating tool paths for some of these other items, and then you know, we will knock these out one at a time. I will do this first. The next one I'll probably work on will be the actual cam, because these parts work closely together. This has got to precisely fit into the bearing. The bearing has got to precisely fit into there. The cam is just an estimate as far as balancing goes or whatever. I haven't done the crazy complicated math, and I may not be capable of doing the crazy complicated math to balance this properly. I may need to enlist the help of somebody a little smarter than me when it comes to the physics of balancing out the eccentric and what weights I need to take into consideration. Do I just need to take into consideration the cam, the needle bar mount, and the needle bar itself, the entire needle bar, a certain portion of the needle bar, because the end barely moves left to right, it's just up and down. There's some complicated equations in doing that. And for me, I look at it visually. I'm going to guesstimate it at this point, and then I'm going to gradually increase and decrease the counterweight, the weight of the counterweight a little bit, and see if I'm getting, just by feel, whether I'm getting closer to no vibration or whether I'm gaining more vibration, whichever direction I'm moving. I'll go back and forth for a little bit. If that gets to be too complicated, I will reach out for help on the scientific end of that. But anyway, so that's it. I'll work on this. I'll work on this. These parts are relatively simple. I want to say I've done most of the body. I think we did a lot of the tool paths on that. I haven't looked at those in a while, so I know what the problem is with that here. Not a big deal. I finally figured that out, and I'll share that with you in a moment, but just want to get you the simulation on this. Let's see, what's the best angle to look at this? All right. And let this run out. Speed this up. And I can't remember if I've changed the tool holder in this simulation or not. I don't believe I have. But I can show you a little bit of that complicated, there it was, right there. What operation? This operation here. Okay. And you can see right here that we would have a collision with this length of a tool holder coming into cut that feature. Now, how much of a collision? I'm not entirely sure, but it would be a collision, especially if this part wasn't already manufactured and it was just the raw stock sticking out there, because that's a much larger piece of material. So, I may have to plan the sequence of machining around what materials left. I could be that close on some parts. But basically what we have here is easily resolved by extending the, what tool number are we on? Bear with me. Close out of that. And open this one up. Which of these are? Contour. It's one of these contours. There it is. Okay, so that's what I have set up here as tool 18. So let's see. Tool 18 is going to be quarter-inch. All right, so what I'm going to do real quickly is I'm going to swap that out for, no, I'm not. I'm going to modify that quickly, and for body, tool 18, I'm going to quickly just change that. We have it in an AR-16 4-inch collet, and I'm going to swap this out for, I believe this one here I just created. Oh, not that one. There it is. All right, we're going to swap that out for the 6-inch holder. And give me 1 second. I'm going to make a note here. Tool 18 to ER16 6-inch. And if not, if I forget to make that change, I will end up with the collision. So now you can see how that's going to come in. It's going to clear these parts here. I believe it will even clear the raw material. Give me 1 second, I can turn that on. Okay, so you can see the raw material will be on there now. And that will just barely clear, but it will clear. So, oops. What are you doing wrong, Mark? Oh, I'm highlighting the wrong item. Okay, so let's just take a quick peek at that. I know how to change that, and that stumped me for quite a while. And it's something related to the fourth axis stuff that I've never really dealt with before. All right, so we're going to come back to looking at this. Now you can see that when I'm cutting down in the bottom of that cavity like I want to, I have clearance. And if I rotate this so the tool's vertical, you can see even when the headstock's down here, I shouldn't be colliding with anything at all. So yeah, that's kind of the logistics I've been working on as to what specialty tools I needed, what specialty tool holders I needed, getting them ordered, getting them shipped here, and then, but we're getting very, very close, and I am back to having this project as one of my key priorities. So I am hoping to, somewhere in the next week, at least get that the deedle bar mount part machined, get you some video on that, and then move on to the cam. I don't see why I can't get those 2 parts done within the next week, as long as nothing major falls into my lap that draws me away from it. But anyways, a little more clarification on where we're at, what we're doing, and on to the next steps. So as always, thanks for watching. Click the subscribe button, hit the like button, share it with your friends. Most importantly, tell me what you think in the comments. Do you like the project? Do you not like the project? Do you see something? What would you do differently? What features would you like in a machine? What features do you think are unnecessary in a machine? Give me comments. It'll be too late to put it into this machine, or at least this version of the machine, but who knows? I might get some ideas. You might have some awesome ideas that can be put into the V2 of this machine, version 2, or might inspire some ideas on the next project. Tell me what you want to see. I really don't know, to be honest. I guess at it the best I can and share the knowledge that I have. And yeah, but I don't do these videos for me. I do them for you. I want you to have a little insight into what goes on in my world and in the world of Needlejig as a community. So as always, thanks for watching, and give me your opinions. Okay, I think the next time I shoot a video, you're going to see some parts, some stuff that I've actually created on the machine. So make sure you're subscribed.